Good afternoon, my YouTube viewers. In this particular video, what we're going to be talking about is exponential smoothing state space. And basically, in a previous video, we did cover exponential smoothing, and we covered simple exponential smoothing. But in this video, we're just going to be covering standard exponential smoothing. And so exponential smoothing state space is a versatile approach that handles error, trend, and seasonality. And so basically what we're going to do is we're going to write a program in Python to demonstrate exponential smoothing state space. And so in order to do that, we have to import 4 libraries to execute the program. So we're going to import NumPy as NP, which is the numeric library, and we're going to import Pandas as PD, which is the data processing library that also makes data frames. We're going to import matplotlib.pyplot as PLT, which is the visualization library. And from statsmodels.tsa.holtwinters, we're going to import exponential smoothing. So statsmodels is Python's statistical library. TSA is time series analysis. Holtwinters is a model for time series forecasting. And exponential smoothing is a function in that. So we're going to generate synthetic sales data to cover a 3-year period. And before we do that, we're going to set the seed. And when you set the seed, what you do is every time you run the program, it initializes with the same values. So you set the seed by typing np.random.seed, and you can put any number that you want inside the brackets. So months equals pd.daterange, brackets start equals 2020-01, comma, periods equals 36, frequency equals ME. So that means you're going to be getting sales data for a 3-year period, or 36 months. Trend equals np.linespace, brackets 100, 300, len months. So that's 36. And so that's going to give you a linear growth. And then seasonality equals 20 times np.sine, brackets 2 times np.pi times months.month divided by 12. And so that's your seasonal pattern. Noise equals np.random.normal. Normal means it's a normal distribution, brackets 0, 10, len months, so that's 36. So that's your random noise. And sales data equals trend plus seasonality plus noise. So now we're going to create a data frame for the sales data. So sales df equals pd.dataframe, brackets, curly brackets, month, months, sales, sales data. So your first column of data is months, and the second column of data is sales. And so sales df.setIndex, brackets, month, in place equals true. So what you're doing is you're taking the month and you're converting it to the index. So now your index is going to be the month. So we're going to fit the ETS model. That's your exponential smoothing. ETS model equals exponential smoothing, bracket sales df, square bracket sales, seasonal equals add, seasonal periods equals 12, dot fit. Forecast equals ETS model dot forecast. Steps equals 12. So you're going to forecast for the next 12 months. So we're going to plot this on a graph. We're going to plot the observed data and forecasted values. PLT.figure, fig size equals 6, 4, PLT.plot, bracket sales df dot index, sales df, square bracket sales, label equals observed data, color equals blue. PLT.plot, brackets, forecast.index, forecast comma, label equals forecasted sales, comma, color equals orange, comma, line style equals dash. And then we're going to put a vertical line in the graph, plt.axp line brackets x equals sales df dot index square brackets -1, comma, color equals gray, comma, line style equals dash, comma, label equals forecast start. And now we're going to put labels, title, and legend in the graph. The title is Exponential Smoothing State Space Model. X label is date. Y label is sales. Then you get a legend, and then you get a grid, which is true. And then so we're going to show it. So now you see you've got your exponential smoothing state space model. Your blue is your observed cells, and then your orange is your forecasted cells, and your dashed line is your forecast start date. So that's it for this video, and this covers exponential smoothing state space model. And the next video, we will be talking about some more time series subjects. So I hope that you decide to watch it.